algebra students, let's go ahead and knock this out for 4.5, 1 through 16. I will be doing the odd ones, so let's get going on number 1, interpreting a scatter plot. A scatter plot shows the amount, x, which is our x-axis, in gigabytes of random access memory, that's RAM, and the prices, which is y, on our y-axis, in dollars of 10 laptops. So this represents the money, this represents the amount of RAM, and these dots represent the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 laptops. All right, so what is the price of a laptop with a RAM of 12 gigabytes? We go to 12 gigabytes, come up, and we see that a laptop is going to cost $800. This says, what is the RAM of a $1,400 laptop? So we'd come over to 1,400, and we'd see the dot there, and we'd come and see that that's going to be 16 RAM. And see what tends to happen to the price as the RAM increases. Well, as the RAM increases, so does the price. The price increases as well. So the price tends to increase as the RAM increases. You have number 2 to do. I'm going on to number 3. Describe the relationship between the data and the scatter plot. This data is going up from left to right on the graph. This has a positive correlation. The y values tend to increase as the x values increase. So the scatter plot shows a positive linear correlation. Number 4 is yours to do. Number 5, these scatter plots are everywhere. There is no correlation here whatsoever. So the points show no pattern. So the scatter plot shows no linear correlation. All right, you have number 6 to do. Number 7 says make a scatter plot of the data, then describe the relationship between the data. Well, when I make a scatter plot of this data, it's going to look like this. And because it doesn't go up or down from left to right, there is no linear correlation. The points show no pattern, so the scatter plot shows no linear correlation. Number 8 is for you to do. Number 9 says the table shows the total amount, y, in thousands of dollars of money a homeowner saves on electric bills, which they call y, years after installing solar panels. So remember, this is showing the total amount in thousands of dollars of money that a homeowner saves in electric bills, okay, for every year. So we can assume then the top numbers are years, right, because time is going to go by independently. And the money here is going to depend on the amount of time that went by. So our scatter plot here is going to show our x, which is time in years, and then our y, which is in money saved. When you do this, you see that the scatter plot shows a positive linear correlation, so you can fit a line to the data. Now, A says write an equation that models the total amount of money saved as the function of the as a function of the number of years after the solar panels were installed. So first we're going to need, remember they're asking for an equation. First we're going to need a slope. So we're going to go to this line. We're not necessarily going to use these coordinates over here, but if we do happen to have two of them that are sitting right on the line, like this one here, we've got 20 and 20, right? And we also have, let's see, negative, let's see, got 5 and negative 5.2, all right? So we have a couple here that we can use that are right on the line. The other ones look like they're a little bit below it or above it. So we're going to go with those. Over here, we're going to put in our linear formula, right? So, our slope formula. So we're going to get 20. That's the one we had here, right? And we're going to minus negative 5.2. And then we're going to take 20, and we're going to minus 5. A negative times a negative is a positive, and 20 plus 5.2 is 25.2. 20 minus 5 is 15, so we have 25.2 divided by 15. That gives us 1.68. When you use this slope, okay, And then we're going to use the points 20 and 20. So now we're going to go and put y equals mx plus b. Remember, our x's and our y are both 20. So we can put 20 equals 1.68. Remember, that was our slope here that we replaced m with, times 20 plus b. Well, 1.68 times 20 is 33.6. We're going to have to subtract 33.6 from both sides. And when we do, 20 minus 33.6 gives us negative 13.6. And that's what b is going to equal. All right. Now we're going to go and we're going to use the negative 13.6. Remember, that's our b in our formula. So we're going to go back to our formula and replace it with negative 13.6. We're going to replace our m with 1.68. So our formula is going to be y equals 1.68x minus 13.6. Right? Interpret the slope and y-intercept of the line of fit. Well, the slope of 1.68 means that the homeowner saves about $1,680. Remember, this was in thousands of dollars, right? On electric bills each year after installing the solar panels. The y-intercept of negative 13.6 means that the total cost to install the solar panels was about $13,600. Okay? Let's move on. Number 10 is for you to do, which takes me to number 11. Number 11 says, your friend says that a line of fit must pass through at least one of the data points. Is your friend correct? I don't think so. The line of fit is a line where about half of the data points are on either side of the line. It doesn't have to pass through any data point to do that. All right. Number 12 is for you to do. Number 13 says measure the height and arm span of 5 people. Make a scatter plot using the data you collected. Then draw a line to fit for the data. Interpret the terms and coefficient in the equation of the line of fit. Well, they want you to measure the height and arm span of 5 people. This sounds like, well, like a sample answer, because, I mean, I don't know what numbers you're going to go ahead and find when you do this. So I'm thinking number 13 is going to have to be just something we go over. It looks like they found the height in inches over here. So they're saying there's 45 inches, 55 inches, 65, and so on. And the arm span is over here. And they're using the same 45, 55, and 65, increments of 10. We're going to find our slope after. They got their line of fit, okay? And they're going to find their slope by taking, well, they're taking 65, right? 65, 65. And they're using the other coordinate 50, 50. So we got 65 minus 50 on both, which gives us 15 over 15, which equals 1. So we got a slope of 1 here. Now, when we use this in our point slope formula, we're going to put y minus, we're using 50 and 50 again. Y minus 50 equals 1 times x minus 50. Well, this is going to give us y minus 50 equals x minus 50. We know this because 1 times x, well, that's 1x. And we're going to put a 1 in front of x. And negative 1 times 50 is, well, negative 50. Now I'm going to add 50 to both sides to isolate my variables. And we see now we have y equals x. An equation of the line that fits is y equals x. That's it. All right, so let's see. Make a scatter plot, we did, using the data. Draw a line that fit, we did. Interpret the terms and coefficient. All right, so as a person is taller, their arm span will get wider. So let's check this out. The slope of the line is 1. This means that a person's arm span increases by about 1 inch for every 1 inch increase in height. The y-intercept is 0. The y-intercept has no meaning in this context because the height cannot be 0 inches. All right, number 14 is for you to do, which leaves number 15 for me. It says, discuss mathematical thinking. Is it possible to fit a line to the data in the tables? So they want to know, can we put a line to this data in the tables? If so, write an equation of the line. If not, explain. So, okay, let's go ahead and do that. If we're doing this, we see, well, negative 12 and 150, right? We're over here at negative 12 and 150. 76, all right? So now we're at, let's see, or sorry, 9 and 7, negative 9 and 76. So negative 9 here and 76. Then 50, right? Negative 7 and 50, so negative 7 right here, and 50, right? So all these are representative of this table. And then on this side, we have 2 and 5, right? And we have 22 and 5, so 22 is going, oh, I'm sorry, 5, and, we had 2 and 5, and then we had 5 and 22. So 5 would be, should have been about right here, and then come up. So not really crazy about the way they made this graph. Because it should have been right here if there's increments of 5, right? And 22 would have been right here. Then 6 and 37. So this one, 6 and 37 too. And 7 and 52. Yeah. And then 9 and 90. Yep. And then 15 and 226. Yep. So the only thing missing that I'm seeing is this 5 and 22. Looks like they forgot to put it in. I'm going to put it in for them. Since this is 40 up here, 22 is just going to be a little bit above half. All right, so there should be a dot here as well. All right. Is it possible to fit a line in the data of the tables? Well, no, because this is not a line, right? Some of it's going down, some of it's going up. The data that do not fit a linear trend. It's not fitting a line that goes, it doesn't go upward, it doesn't go downward, it's just kind of going up and down at random. All right. Number 16 is yours to do. And looks like that's all the homework. So I'll see you in class for grading. Good luck with the rest. Have a great night.